Welcome back to geometry. We have a rather short lesson today, 5.3, and we're dealing with medians, altitudes, and angle bisectors, and they are parts of triangles. So the first question that we asked is, how many medians does a triangle have? Well, when we look at a median, note that a median is not a mid-segment. Let me just get this to the pen. Alright, so again, this is not a mid-segment. It's somewhat similar to it, but what it does is we're going to start at an angle, which is the same as a vertex. So when it says a segment that starts at a vertex, that's a name for an angle. So it starts at an angle and goes to the midpoint of the opposite side. So if I were to start from vertex or angle A, and draw a segment to the other side that's going to cut BC in half, it looks like, and we'll just do this on our best guess, it looks like about right there that these two sides are now each congruent. Now when I do that, I'm going to create a new point. It's going to be called point M. And so I can say AM is a median because M is the midpoint of BC. Alright, and we're going to do the same for the other two angles. So in a triangle, you will have three medians. No more, no less. Again, a median is different from a mid-segment. You can look at your notes from last unit as to what makes those different. And they want us to draw in three medians. So we just drew in our first one. Let's go from angle C next to the other side. And it's going to be hard to draw a straight line, but we'll do our best. Yikes, that's not too good, is it? So these two sides are now the same. And let's call this point O. So I can say that CO is the median because O is the midpoint of AB. And we're going to do the same from angle B. We're going to draw a segment that's going to cut AC in half. We'll put 3 marks here. These two segments are each congruent, therefore N is the midpoint of AC. So BN is a median because N is the midpoint of AC. Alright, the next new term, before we do that, we're going to draw medians on this shape as well, just for practice, but we won't label everything like we did down here. So from angle C, it looks like we would go about right here. We can show that with a mark and a mark. Angle B, about right there, 2 marks, 2 marks. And angle A, all the way down, 3 marks, 3 marks. Alright, now one important fact that I forgot to mention is that see where these three medians meet. Alright, where these three medians intersect is a very important point. It has a name, and this name is called a centroid. And think of it as the center. It meets at the center, so we call it a centroid. And so again, we're going to show this point of intersection where all three medians meet. This is called a centroid. Alright, next term we have is altitude. And an altitude is a segment that starts at a vertex and angle and is perpendicular to the opposite side. Since we have 3 angles in a triangle, there's going to be 3 altitudes, just like medians. Okay, and so the whole key here is we want to draw a segment from angle D that's going to create a 90-degree angle with segment EF. Now, we have to be smart about how we do this. If we just draw a line straight down, it's not going to create a 90-degree angle. So it looks like we have to draw this line over to the left, and that wasn't all that great either, but we're going to say this is a 90-degree angle. We're going to do the same from angle F, and 90 degrees, 90 degrees, and the same from angle E. And again, these aren't going to be perfect, but just our best drawings. All right, I went ahead of myself. DP. So let's think about that. DP. Oh, first off, D is up here. I don't know why D is showing over here. So here's point D. Let's label this point P with this new point. So DP is an altitude because DP is perpendicular to segment EF. Next we have EQ. So here's E. It's going to end at this point. Now that's called Q. And we can say EQ is an altitude because EQ is perpendicular to DF. And then last one, FR. Let's put a point here. This is going to be R. And we can say FR is an altitude because FR is perpendicular to DE. Alright, and just like before in our first problem, we're going to do the same in our obtuse triangle. Now, this time it's going to be very challenging to draw our altitudes, and here's why. From angle E, it'll be easier. We can draw, looks like if it comes right here, oof, that's close. Put 90-degree box, 90-degree box. Okay, but from angle F, if I draw a line from angle F, it looks like impossible that we'd be able to make a 90-degree angle. And actually it is not possible with the way that this drawing has been made. So we have to extend out the sides. And here's why. When we extend out our sides, like so, now you can draw from angle F and draw a line to where this will now create a 90-degree angle, and we can put a box right here. And we have to do the same thing for the other side. And so DE, we want to extend out, we're going to extend out EF. And we're going to draw down our altitude from point D. And it creates a 90-degree angle. Alright, what's also going to be important is where these lines or these three altitudes intersect. And just like last problem at the median, it was called a centroid. This time, these 3 points intersect at what's called the orthocenter. Alright, now how are we going to remember this? Well, here's how. The term ortho. Alright, ortho reminds me of orthodontist. So when we go to the orthodontist, did I spell that right? We go to get braces. And if you have a fear of heights, you need to brace yourself for the altitude or the height that's coming. Since these are altitudes, you will think of the term brace for height, and think of braces and orthodontist and orthocenter. You will not find that in any geometry book. That is from yours truly. So we want to do the same thing for the shape to our right, and we can tell as it stands that we don't know where those three altitudes meet at. However, if we were to expand these lines out, or expand out the altitudes, we would expand this one down, we would expand this one out, and this one out. Whoops. And it looks like that they would touch about right there. So let's change colors, and this would become our orthocenter, which is the point of intersection of all three altitudes. Alright, we're almost finished. We have some more terms. In an isosceles triangle, the median, altitude, and angle bisector of the vertex angle are all the same. The three medians of a triangle will always meet at a point inside the triangle called the centroid. The three altitudes of a triangle will always meet at a point called the orthocenter. Alright, and then they also throw in a term that's review called angle bisector. So before we answer this, let's draw a triangle. And then let's draw 3 angle bisectors. So if we draw one angle bisector, it's going to cut these 2 angles in half. A second angle bisector will cut these 2 angles in half. A third angle bisector will then cut these 2 angles in half. And just like we've done on the previous 2 problems, the points of concurrency where the 3 lines meet, or where the 3 angle bisectors meet, is going to be called the end center. So the 3 angle bisectors will meet at a point inside the triangle, and this time for the angle bisector it's called an end center. Alright, and then our last question is asked, can you find the centroid, the orthocenter, and end center of the triangles above? Yes, we already have. We showed that. Thanks for joining us. I'll see you next time.